Okay, like I said, this is a long problem. I'm going to do something separately. For example, um, as an aside, really not. I want to show that this thing is equal to that, all right? I'm going to use integration by parts to do it, all right? So let me go to the whiteboard and write that integration down. And this is something we're doing separately. It's a long problem. I don't put all the details in the notes, by the way. So let me take a look, and let's see what we got over here. We have an integration. The integration starts at 0, and it goes to 1, and we get 1 minus x, excuse me, times the natural log of x dx. And they claim that's equal to minus 3/4. All right? Now, a couple of things I know about this over here that it's an improper integral. And the reason that as you approach 0 from the right-hand side, the natural log goes off to minus infinity. So I'm going to rewrite the problem. The limit as a goes towards 0 from the right side of it. This will be a now. And then I get 1 over here. And this will be 1 minus x, natural log of x, dx. All right? I'm going to do a little bit of side work on this. And what I'm going to do is I want to figure out what this guy's antiderivative is, and then I'll do the limit. So it's going to be limit as a goes to 0 from the right side. And what I got to do is I got to do this. By the way, there's going to be a limit over here. This goes from a up to 1. I don't know the antiderivative, though. So let me go through that with you. There's many ways of doing it. But let's take a look at it. I'll say u equals the natural log of x. And then du would equal 1 over x dx. dv would equal 1 minus x dx. And then v would equal x minus x squared over 2. The constant integration is going to come into it later, but since we have a definite integral, I'm not too worried about that. So what do you get over here? You're going to get uv, which is the natural log of x, times x minus x squared over 2. All right, then what do you get over here? It's going to be minus, well, it's going to be, again, let me just make sure you follow what I'm saying over here. And this is the u, right? And this, whoops, sorry about that. I went too far with that highlighter there. Sorry about that. Let me go back over here. This is the u, and this is the dv. So the thing we're using over here is u dv equals uv minus v du. All right, let's write this down now. So let's see, du is 1 over x dx, and the v is x minus x squared over 2. All right, I'm going to try to do this. I'm going to pull this over here now. This is equal to the natural log of x. I'm going to put a 2 here, and I'll put down 2x minus x squared. All right, and then I got to do that integration. All right, let's see what you get there. I'm going to distribute, and you're going to get 1 minus x over 2 dx. All right, let's integrate. And what do you get there? Let's see, natural log of x. Let's see, let me just simplify a little bit. 2 here, and then I get 2x minus x squared. All right? Minus, well, this doesn't look that bad. It's going to be x, interval 1 is x, minus x squared over 4. And again, there's a constant integration, but I'm not too worried about that. All right? So let's keep going. And looking at this thing, I'm just going to write down 2x, the natural log of x. Whoops, I didn't mean to put the 2 there. That was a mistake. Let me erase that. I just noticed that. X, ln x. You know what, that really doesn't add much to the problem, so I'm not going to do that. But let me simplify that other part. So natural log of x times 2x minus x squared. And what do you get over here? You get over 2. And this will be minus x plus x squared over 4 plus some constant integration. I want to remind you, the whole point of that was to do this guy's antiderivative. And I found the antiderivative, this thing over here. All right? So natural log of x. I'm going to jam that in there now. You know what I'm going to do? I'll just do it at the bottom now. I guess I should write this in just to be neat, though. Natural log of x times, got to scroll down again, 2x minus x squared over 2. And then it's going to be minus x plus x, x squared over 4. All right. So what I'm going to do is write that limit down now. So this integration we're trying to do over here, which goes from 0 to 1, 1 minus x, natural log of x, dx, is the limit as a goes towards 0 from the right side of this thing. Over 2 minus x plus x squared over 4. And this is going to go from a to 1. All right? Well, a couple of things I can do off the top of my head right now. I can certainly do the upper limit. And the natural log of 1 is 0. And then you get, you know, this upper limit, you're just going to get minus 1 plus 1/4. And then I get this limit problem. It's going to be minus the limit as a goes to 0 from the right. And we get a problem over here. You get the natural log of x. And then you're going to get 2x minus x squared over 2 minus x plus x squared over 4. Well, my main issue over here, whoops, I put the a over here. Sorry, I forgot to put that down. My main problem over here is that, you know, the beginning of it's pretty easy. I mean, this minus 1 plus 1/4 is minus 3/4. But the limit is causing some trouble over here. But I do know that a couple different things in a limit over here. I know that this is going to 0, that's going to 0. So I'm really left off with evaluating, I'll write that down for you, minus the natural log as a goes, as a goes towards 0 from the right side. And I can pull a half out. And then what are you going to get over here? The natural log of a. And then it's going to be 2a minus a squared. All right? Now again, looking at it, as a goes towards 0, we have a competition in indeterminate form that this will be going to minus infinity and this will be going to 0. So we have an indeterminate form. So the way I'm going to just rewrite that, I'm going to try to use L'Hopital's rule on it. And like it's more side work now. But I'm going to rewrite it a little bit differently. I'm going to write this as the limit. I'm going to use the letter x because it's easier for me to write it. X goes to 0 from the right side. I'm going to write this as the natural log of a on top. And then on the bottom, I'm going to write this over here. I'm going to write it as 1 over, let's see, 2a minus a squared. So now I'm getting the L'Hopital form. And the L'Hopital form, the top's going to minus infinity, and the bottom's going towards an infinity as well, by the way. All right? So what I'm going to do now is, let's take a look. I'm going to take a derivative down. Use L'Hopital's rule. Limit as, you know, I did the a again, and I apologize for that. I got to erase this again. Sorry about that. I said I was going to do x, and I write down an a instead. So it's going to be the natural log of x. And then on the bottom, it's going to be 1 over, let's see, 2x minus x squared. Right? And the question is, what is this equal to? So limit x goes to 0 from the right. I'm using L'Hopital's rule. It's an indeterminate form. The derivative top is just simply 1 over x. The bottom a little more complicated, right? So I'm going to write this on the side, 2x minus x squared to the minus 1. Its derivative would be minus 1, 2x minus x squared to the minus 2. That's not so bad, right? And the derivative of the inside is going to be 2x. I'm not 2x. I'm really, it's early in the morning for me. So it's going to be 2 minus 2x. all right? So let me write that down for you. You're gonna get -1, and then you're gonna get, well, let's see, I think I'd write down as 2x minus 2 now. Get my eraser out. So 2x minus 2 over, that bottom is going to be 2x minus x squared. All right, let's see how I did there. Yeah, I think I did okay. I'm going to rewrite that. Limit as x goes to 0 from the right side. And what do you get over here? You certainly get an x. I'm doing the top, by the way. And then it's going to be 2x minus x squared. And what do you get on bottom? You're going to get 2x minus 2. All right? Now, granted, it kind of slowly going through, but I do want to go through, the kind of details that I would recommend a student look at before coming up to the conclusion of this one over here. But just kind of looking at the top, and what I would do is I'd factor out an x from those two terms over there. And I would get x times 2 minus x, but that's being squared, by the way. And then I get an x over here, and then I get 2x minus 2 over here. All right? Now what happens over here, limit x goes to 0 from the right side. I do know that one of those x's cancel because not 0, so I get x, and then I get 2 minus x squared, and then I get 2x minus 2 on bottom. And what's this limit equal to? The limit on top is just 0. That's pretty simple to do. And the limit on bottom is just simply minus 2, so I do get 0. All right? Well, that was a long road, wasn't it? And what I found out over here, I found out that this other limit over here just completed is just simply 0. So I get minus 3/4 minus 1/2 times 0, which is 0, which is minus 3/4. And again, that's what we're asked to show. And I want to be honest with you, the problem, to me, it presents problem on top of problem, by the way. Let's go back and finish it up, though. Thank you.